Hello, this is Yoshinori Hayakawa speaking. I will introduce newly invented computer Abacus, which was developed from new computer numerals. First, I will explain briefly about computer Abacus. This bead is 1. And now it's showing 0. This bead is 2, 4, 8. And yes, first you have to remember these number numerals. This blue bead shows for subtraction, it's minus value. This is 1, 4, 2, 8, and 10, 20, 40, and 80, and 100, 200, 400, and 800, and so on. Yes. I will explain more in detail using computer Abacus. This is bead 1, and now it's all the beads are down and up, so it shows 0. Okay, sorry, I'm making 0. Yes, and this is 1. 1 is to raise this bead. This is 1, and this is 2. This is 4, and this is 8. Please remember one rule of binary system, that is two beads is the same with one bead, one rank higher. This is 1, and this is 2. And these one bead is raised to bead 2 at one rank higher. And this is 2, and add one bead more, that is 3. And this is 3 plus 1 is 4. But 2 beads here is raised to 1 bead here, and 2 beads here, that is 2 beads 2 is raised to 1 rank higher, that is bead 4. And 4 plus 1 is 5. 5 plus 1 is 6. These 1 beads is raised to as bead 2, that is 6, and this is 7 and 8. And this is 8, and 9 and 10. 10 is this bead, 2 beads 1 is the same with 1 bead 2. This is 10, this is 2 and 8. 2 and 8. 2 and 8 makes 10. That is 10. This is raised to 1 order higher here. So please remember one rule. 2 beads at the same rank is the same with 1 bead, 1 rank higher, and so on. This is 2, 4, 8, and this is 2 bead 8, that is 16, but it is not necessary to remember the number. And these two be the same with this one, and this one is the same with this one, and this one is the same with this one. Yes. If you these are actual numbers, but it is not necessary to remember these numbers. This is double of 8, this is double of double 8, that is 16, and double of 16 is 32, and double of 32 is 64, and double of 64 is 128. But it is not necessary to remember these numbers. So now you are ready for calculation. Addition, subtraction, multiplication, and division can be done without remembering a multiplication table or addition table. Wait a minute. Sorry, yes. I will explain with a simple addition, that is 7 plus 8. This is 1, 2, 3. I know, 1, 2, 4. That makes 7. Yes. 1, 2, 4, 2, 1. 1, 2, 4. That makes 7. 7 plus 8. Addition is to join two numbers. That is 7 plus 8. That is 7 plus 8. But this makes 2 and 8. 2 and 8. 2 makes 10. So it is raised 1 order higher. That gives 15. Let's calculate. Let's show. That is 2 plus 8 is 15. Calculated by computer numerals, and I will show you 7 plus, wait a minute, something wrong. 7 plus 8 equal 15. Yeah, it's all right. Let's do another addition. Let's make the abacus 0. This is 0. Okay. And the next addition is 86 plus 7. Uh, 86 plus, this is 8 and 6 and 7. 1, 2, 4. That it makes 7. And these 2 4 B's is raised to as 1 8B, and this makes this 2 and 8. That makes 10. That is this one. Okay, so the result is 8 and 1, that is 9 and 3. That is 93. Let's calculate using a calculator. Wait a minute. 86 plus 7 equal 93. Yes, it's all right. Let's do another calculation. $38 plus 29. Let's make the abacus 0. Yes, it's all right. 30. That is 2, 1, 1, 2, 38 plus 29. Okay? These 2/8 bead, if 1/8 bead is lowered, then it makes 2 4 beads. If one bead is lowered, it appears as a 2 beads 1 rank lower. And this 4 is still lowered as 2 beads. And this makes 10. This makes 10. Okay? Okay. And this change this one. So the result is 67. Let's try by calculator. 38 plus 29 equals 67. It's all right. Okay. Let's try another addition. Let's make the abacus 0. First 49 plus 929. Yes. 49 plus 929. Yes, all right. So this makes 1 bead is the same one with 1 2 bead, and this makes 10. There is one order higher. So the result is 978. Let's make certain by a calculator. 49 plus 929. Okay, that is 978. Yes, 978. It's all right. Let's try another problem. A little complicated. First, please make the abacus 0. Yes, 967 plus 892 plus 786. Okay. If 967 plus 892 and 786 is added, what will be the answer? First, all right. Yes, it's all right. It's all right, but all right. I have abbreviated important explanation, but this time it's all right. This is 10, so it is raised 1000, and this makes 10, so it is 2000, and this is 10, 100, and this is heightened one rank, and this makes 10, and this makes 2, and this makes 10, and this is raised one order. So the answer is 2645, right? 2645. Let's try by calculator. Wait a minute. 967 plus 892 plus 786 equal 2645. Wait a minute, something is wrong. Wait a minute. 967 plus 892 plus 786. That is 2647. 2645. Now its addition is over. Let's try subtraction. Let's try 87 minus 9. 87 minus 9. 9, that is 8, 1, okay, okay. First, this blue bead and ordinary bead cancels out. This is subtracted, and yes. Wait a minute. I'm thinking. Wait a minute. This is yes. This blue bead, 8 blue bead, that is minus 8, that is to be cancelled. So I'll make this one, and this is the same with 10. Okay, and this cancels out. Okay, so these two are raised. These two are raised. So the result is 70. We recognize that there remains no blue bead. So the result is 78. Let's try by calculator. Yes. 87 minus 9 equal 78. Yes, it's all right. Let's try more complicated subtraction, but first make the abacus 0. Yes, 700, 1, 10, 100, 770, 72. 772 minus 486. Okay, 486. 772 minus 486. Okay, so this cancels out. This is the number to be subtracted. This cancels out. Okay, and the next is here. Okay, I made a mistake here. This should not be raised, but this one should be raised. Sorry, I made a mistake. Sorry. This 100 bead is lowered by 10. 100, and this cancels out. Okay, this cancels out. This goes up and goes up, and since this cancels out, okay, but still we remain a blue, that is to be subtracted one. This 10 beads is lowered. Yes, and this 8 bead is lowered as 4 bead, and this cancels out. And please make sure no blue beads remains. So the result is 242. Okay. So the result is 282. 282. Okay. Let's try by calculator. 772 minus 486 equal 282. 280. Wait a minute. I made a mistake. Sorry, I made a mistake. Sorry, I made a mistake. 772 minus 286. Okay. Make certain 770. All right, I made a mistake. 72 minus 4. No, this is not correct. 486. Okay, this time it's okay. So this cancels out. Okay. And here remains 80. So this is cancels out by this one. This cancels out, and this cancels out. And this is 10. This is lowered, and this cancels out. 600, no, 286. 286. I'm sorry, I made a mistake. I hope this time I'm all right, but we'll make it certain. I'll make it certain. 772 minus 486. Okay. This cancels out, and here it is. So it is lowered by 10, and this cancels out, and this cancels out, and this is lowered by 10. This is lowered, and this cancels out. No blue bead remained. This is made higher. This is made higher. So the result is 286. All right. This time I'm all right. So let's try again. Sorry, I made a mistake. 772 minus 486 equal 286. Yes, this time I'm alright. Sorry, I have not repeated the calculation, so I made a mistake. Now I'm going to explain about multiplication and division. First, I will explain about multiplication, and next in division. Multiplication, 6 times 7 is add 7 times to 0, and so on. This is the computer abacus, and central bees are used for multiplication, and these blue bees are used for division. Yes. First, I will explain again about the number, and this is 1. These bees are 1, and these bees are 2, and these bees are 4, these bees are 8. And these blue bees are minus, negative. Yes. First, I will explain about computer abacus again. Lower bees are all down, and upper bees are all up, and blue bees are all down and up. This shows 0, and this bees is 1, and this bees is 2, this bees is 4, this bees is 8. First, I will explain the system of binary system briefly. That is 1, this is 1, and this is 2. 2 bees 1 is the same with 1 bee 2, and 2 bees 2 is same with bees 4. 2 bees 4 is the same with 1 bees 8. And 2 bees 8 is the same with this bees, that is 16, but it is not necessary to remember the number 16. And 2 bees 16 is the same with 1 bee 32, and 2 bees 32 is the same with 1 bee 64. But it is not necessary to remember 16, 32, and 16, 32, and 64. Not necessary to remember. All that you had to remember is 2 bees in 2 bees is the same with 1 bee 1 rank higher, and so 2 bees is the same with 1 bee 2, and 2 bees 2 is the same with 1 bee 4, and 2 bees 4 is 4 plus 4 is 8, and so on. Let's explain about the how to put the number on Abacus. This is 1, and 1 plus 1 is 2. Added 1 and 1 is 2, so it is the same with these 2. And then add 1, that is 3, and this 3 is 1 and 2. And this is 4, 4b, 4, and this is the same with 2b is 2, and this is the same with 1b is 4. This is 4, and add 1 is 5, this is 5, 1, 4 is 5, and 6, this is 6. 6 is the same with this one. This one is 2, 4, 6, 7, 8. 8 is this is 8, and 9, and this is 10. 9 is 1, 8, and 10. 10 is the same with 2, 8. If this appears, 10, 2, 8 appears, it is the same with 8. For multiplication, you have to remember another 3 numbers. That is 10 plus 10. 10 plus 10 equal 20. It is because this is 2, and this is 2 times 2, 2, 4, 8, and 8 times of 2, so it is 20. And 20 plus 20 is these b's. That is 40. 40 is 8 plus this one, blank, 8 blank, and this one. And it is because this is 4, and double of 4, 4, double of 4, 2 times 4, 4, 8. So in addition, it is 2 times and 8 times 4, that is 40. And you have to remember one more setting of beads. This is 40 plus 40. And this is the same with this one, and this is 80. It is 80 because this is 8, and double of 8, and blank, and 8, 2, 4, 8, 8 times of 8. So in addition, it is 10 times of 8, so it is 80. Now you are ready for multiplication. First, we have to put the bead abacus 0, okay, 0. 6 times 7 is 6 added to 0 7 times. This is 6. And 7, if it is this, it is added, that is 1, 2, 4. 4 is added 7 times, it becomes like this. And 2 6 is 4 and 2, and 2 is added 7 times. 1, 2, 4. So this is 4 added 7 times and 2 added 7 times. That is 6 added 7 times. And this is a result. And I will change the abacus. This is 4, 2 times 4, blank, and 8. 2, 4, 8. That is, in addition, it is 10 times 4. That is 40. Yes. So the result is 42. 6 times 7 is 42. Let's make certain by calculator. 6 times 7 equal 42. Yes, it's all right. Then we will try another multiplication, a little more complicated. First I have to make the abacus 0, make certain that the abacus is 0, and 42, sorry. Okay, something is wrong. Yes, okay. 42 42 multiplied by 54. 54. So I will multiply 42 by 54. First, I'm adding 40 50 times. So 5 is 1, 2, 4. So if it is added 5 times, the 0, 1, 2, 4. So it appears here, but we will shift the order by 2. Sorry. Okay. 1, 2, wait a minute. 1, 2, 4. This one. 1, 2, 4. And I will add 0 4 times. 1, 2, 4. So it appears 1, 2, 4 here. And this vanishes. And then we're going to add 2 50 times. That 5 is 1, 2, 4. So 1, 2, 4. So it appears here 1, 2, 4. But we are going to shift wait a minute. Yes. 1, 2, 4. 1, 2, 4. Okay, and then 50 vanishes, and we are going to add 4 times. 1, 2, 4. So it appears here, but we are going to shift it 1, 2, 4. So it appears. Wait a minute. 1, 2, 4. And so this 4 is cancelled out. So this is a result, and sorry, this is wrong. And this is 2 and 2, 4, 8. So it is 20. So it is 20. So it is changed here. And this one is lowered by 1 rank, and this is 2, 4, 8. So it is 20. All right. So the result is 2, 2, 6, 8. 2, 2, 6, 8. 2,268. So I will try by calculator, make certain by calculator. 42 multiplied by 54 equal 2268. Okay? Yes. So the multiplication, simple multiplications are over, and I will try another more complicated multiplication. Let's multiply more complicated new numbers. 579 multiplied by 94. 507 9 multiplied by 94. Yes. Okay. First, I will multiply. This is 500. 400 by 9 times. 1, 2, 4, 8. So it comes, if 4 is multiplied, it comes here, but it is raised 2 order higher, so it comes 1, 2, 4, 8, and this comes 1, 2, 4, 8, so it comes here. So yes, and then we multiply 4 times, 4 times 1, 2, 4, it comes here. Okay, and 1, 2, 4, it comes here. Okay, so it is cancelled out. Next, we are multiply 7 by 94. So 1, 2, 4, 8. So it comes here. 4 is multiplied by 9. It comes here, but it is raised 2 order higher. So it comes here. And this comes 1, 2, 4, 5. 1, 2, 4, 8. Sorry. And this comes 1, 2, 4, 8. So it comes 1, 2, 4, 8. Yes, okay. And then we multiply 7 by 4. 1, 2, 4. It comes here, so it's 4, and this comes 1, 2, 4, it comes here, 1, 2, 4, it comes here, and it cancels out. And then we multiply 9 by 9. So first we are going to multiply 8 by 9, 1, 2, 4, 8. So it comes here, but it is raised 2 order higher. So it comes 1, 2, 4, 8. Yes, okay. And this is 1, 2, 4, 8. Yes. 1, 2, 4, 8. Yes. And then we multiply 9 by 4. 1, 2, 4. It comes here. 1, 2, 4, it comes here, and it comes 1, 2, 4, it comes here, and it cancels out. Okay, and this is the result. First, we are going to. This is 4, 2, 1, 2, 4, 8. This is 40. Okay, and this is also 40. And this is raised, this raised 1 order, and this is 40. And this makes 10. And this is 8, 2, 4, 8. This is 80. 80, so it makes 10. And these one rank, and they make 20. 20. Okay, and this is lowered by 1 rank, and this is 20. This is 20, so it makes 10. And this is still lowered, and this makes 10. So the result is 5, 4, 4, 2, 6. 5, 2, 2, 5, 4, 4, 2, 6. 100, 1, 10, 100, 1,000, 44,200 wait a minute. 44,426. Wait a minute. Five, sorry. 54,426. This is 5, so 54,000. Sorry, I made a mistake. Let's multiply by calculator. 579 multiplied 94 equal 54,426. It's all right. Next, we are going to achieve division. Division means, for example, I will show you 72 divided by 8. That means how many times 8 can be subtracted from 72 until the remaining becomes 0. Alright, I will achieve that one. For division, we are using this blue beads. 72 divided by 8. Okay. Next, we are going to do division. For division, for example, this is the example, 72 divided by 8. That means how many times 8 can be subtracted from 72 until the remaining is 0. For division, we use this blue bead. Alright, let's do 72 divided by 8. That is 72 divided by 8. Okay? First we see that from 7, 8 cannot be subtracted, so we're going to change the form. So this is 40. 40 is 40. 1, 2, 4, 8. 40. And this is 20. 20 is this, and 10 is this, and Wait a minute. Yes. And we are going to subtract from this one 8. How many times 8 can be subtracted from this one? This is 8 to 4. So from this one 4 times 8 to 4 times, okay, so it's 4 and 4 and 8 to 4, okay, and this vanishes. Blue bead and white bead vanishes, subtracted, and we have here this is raised one rank, and this is raised one rank, and 8 to 4 we have another we can subtract another 8 4 times. Yes, and this 8 to 4, yes, and this vanishes, and these two beads is raised one rank, these two is raised by one rank, and this is 8, so 8 can be subtracted from 8 once, so it is okay, and okay, and this vanishes, and leaving nothing, that is 0, and this 2 4 is raised one order, so the result is 9. So 72 divided by 8 is wait a minute, okay, all right, is 9. Sorry, I have lost. Yes, it's 9. 8 1 9. So let's try by calculator. Uh, 72 divided by 8 equal 9. Okay, it's okay. Okay, let's do more complicated division. First we make the abacus 0. $774 divided by 43. That means how many times 43 can be subtracted from 774 until the remaining becomes 0. $43 774. Okay. Yes. First we subtract 7 once, okay, once, and this is 1, once, 4 and 3. Okay, and this cancel out, and this cancel out, and this cancel out. Okay, so 344. But we can't subtract 4 from 3, so this is this 300 lowered by 1 order. 20, 20, and 10. Okay, so this is 4, 2, 4. So 4 can be subtracted from this one 40 times. Okay, and 4 to 4, okay, and 3, 4 times 2, 4, so wait a minute. Okay, yes, 2, 4, and 4, yes, and this vanishes, and this vanishes as well, but remaining this one as well. So this is lowered, and this is still lowered 1 order, and this vanishes, and yes, I'm thinking, wait a minute. This is 1, 2, so it can be subtracted, 4 can be subtracted from this one 2 times. So this blue bead is raised, and 3 multiplied by 2. Yes, this one, so this one, and this vanishes, and this yes, this vanishes as well, and this is lowered by 1 order, and this is lowered 1 rank, and this vanishes. And this is raised 1 rank, as well, and it can be this is 488, so another 4 can be subtracted another 2 times, so 4 multiplied by 2 is this one, and this one multiplied by 2 is 2, 4, 4, 2. Okay, and this vanishes, and this vanishes, this vanishes. So there remains nothing. So, but this is to be changed. This vanishes as well, and this is a 1 rank. This is a 1 rank. So the result is 1 and 8. That is 18. So 4, 18, 1, 8. So I will calculate by calculator 774 divided 43. 774 divided by 43 is 8. Wait a minute, something wrong. 774 divided by 43 is 18. Yes, it's all right. All right, we're going to do division more complex. 855 divided 48. All right. First, I will make the abacus 0. Uh, 855. Okay, 855 divided by 48. Okay. First, 48, 855. Okay. First, probably it is difficult to subtract 45 from 48 2 times. So I will subtract once. And so is 48. Okay. And this is lowered 1 rank, and this vanishes. And here, wait a minute, something is wrong. Sorry, I made a mistake. Okay. First I will subtract 45, 85, 48 once, and the result is 40, 8. This is lowered by 1 rank and this vanishes. And this one, it is lowered and this vanishes. The remaining is 37 and 5, so it is not possible to subtract 48 from 37, so we make this one lower. This is 20, this is 10, okay? Okay. The order is lowered by 1. All right. I think 4. This is 4. 4, 2, 4. It is. I think it is possible to subtract 4 times 48 4 times 4 2 8 2 4, yes, and this 8 is 2 4, okay. And this vanishes, and this one, this is 20, 40, yes, we make this 40, this one, and this vanishes, okay. And I will subtract from, this is 4, probably two more times, 2, that is 4, and 8, wait a minute, I made a mistake here, probably it's this one, 8, probably this one. I'm sorry, I made a mistake. Sorry. Sorry, I made a mistake. Yes. I'm going to subtract, divide 855 divided by 48. That means from 855, how many times 48 can be subtracted until the remaining is 0. Yes, so 855, okay? Okay. 855, okay? And 48. This is 85. But I think it is impossible to subtract 2 times, so I will subtract once, 10 times, yes. That is 4 and 8, okay? And this is lowered by rank, and this vanishes. And here remains negative, so this is 10, and this vanishes. The remaining is 37. We can't subtract 48 from this one, so this is lower. This is 20, and this is 10. Okay. This is 42. I think 2, 4. We can subtract 4 times 48. 4 times 4, 2, 4. 4, 8, 2, 4. Okay, and this vanishes, and this this is 20, so wait a minute, 40. This is 40, and this vanishes. I think we can subtract 2 more times, and this one and this one. Okay, and this vanishes, and this one, this is 20, and this vanishes. We can subtract. Wait a minute. Two more times. Wait a minute. No. It is not good. Once. 4, 8, and this vanishes, and this vanishes. So the remaining is 39. Is it okay? So the result is 17. And remaining is 39. All right. Let's calculate. 855 multiplied by 48 equals 17.8125. So in order to calculate the remaining, I will subtract 17. So this is the remaining number, and I can calculate the remaining number by multiplying multiplying 48. Yes, the remaining is wait a minute. I made a mistake. Okay. 855 divided 48 equals 17.8125. So in order to calculate the remaining, I will subtract 17 and multiply the by 48. So yes, so the remaining number is 39. Okay, so I finish by this one. So using this Abacus, computer Abacus, you can add, subtract, divide, multiply and divide without remembering addition table or multiplication table. And this Abacus can be used as a binary Abacus as well. Thank you for listening. I think this can be taught to people who do not know how to calculate in short time. Thank you for listening.